Hello again, my dear students, and welcome to part number 2 with this case study related to an office building in Nairobi, in Kenya, where we are considering the lighting loads for this building. And in the previous video, we have investigated together the energy management and the energy auditing level B with the possibility of replacing the current loads or the current sources with a new sources with relatively lower power. However, we have recognized that due to the limited lifetime of these sources, which was only to 2,500 working hours, this leads to when we calculate the saving, we found that the saving are relatively less with respect to the lifetime. Here you can see the payback period, which is simply the division between the expected saving per year and the total price of this alternative or this replacement cost. And here, as you can see, we just subtract the payback period from the lifetime, and you can see that all numbers are showing negative numbers with relatively high amount, which means that it's not efficient by any means to make this replacement, because this replacement will not break even in the system and will not have its added value, definitely due to the very limited lifetime. You can resolve this part by only changing one number, which is the lifetime here, based on what we have been given in the sheet. Here you can see the sheet. So based on what we have given in the sheet, that the working hours are 2,500 working hour. If you make this, for example, 20,000 working hours, then you will find a totally different answer, because in this case, you will find that most of these sources will be economically of benefit due to the long lifetime of the new alternative source. But now let's go to the smartening part, or what we can call level C of our decision. So in level B, we have take the decision to choose those sources which are of the minimum power consumption, which is the minimum energy saving. And as you can see here, we can go here and we can start calculate what we can call the total energy per day. Which simply will have the unit of kilowatt hour per day. So this is the direct multiplication of the total power times the time, as you can see. And we can make here this summation, but here I have a mistake that I should divide by 1,000 to convert it to kilo. And then I can make this. So as you can see, this is the total power per, of course, per quantity, per lighting source. And then we can calculate here the total energy. So we can make here a tab for total energy consumed per day in kilowatt hour per day. And this will be simply equals to this sum. And so this is 55 kilowatt are the total energy needed per day in order to operate this different lighting source, as you can see in this example. So now we can go to the decision number 2, which is here. A motion connected sensor can be applied with 5 years expected lifetime and a price of 0.8 per lighting unit, leading to an effective reduction of 35% in the operating time. Of course, energy and time are directly proportional. So when you reduce the operating time, which is this time, when you reduce the operating time by 35%, this directly means that you are going to reduce the energy by 35%. So what we are going to discuss now is it worthwhile to take this decision? I mean, is it worthwhile to take the decision of inserting a lighting motion detection sensor in order to reduce the operating time and then in order to reduce the overall energy consumption or not? Again, this will be considered from a techno-economic visibility perspective. So, first of all, we can here define another total, and I will call it enhanced total energy consumption per day, and I will put here between brackets after applying the motion sensors. So this new system should reduce 35% of the total energy. So the new energy is simply this number multiplied by 0.65. So this is the new total number, which represent a reduced system needed. Okay, perfect. Now, this is the reduction. So we can here calculate the saving. So we can say that energy saving still per day here we can make the energy saving, which will be simply the subtraction of these two sources. So I'm saving 19.2 kilowatt hour per day. So in terms of money, I can translate this to money. In dollars. So this will be simply this number times 0.16, which is again the expected torque. Okay, so I calculated this is the amount of saved money per day. So the amount of saved money per year. Okay, so this will be simply equals this number times 365. Again, so I'm going to save about $1,125.67 per year. Now, in order to check to what extent this is visible, we have to go to the cost and the lifetime. Let's go to here. So the cost is 0.8 per lighting unit dollar, and the lifetime is 5 years. So to calculate first the cost, so let's go first to per lifetime. So per lifetime, I'm going to say okay, this number multiplied by 5. So this is the total amount of money to be saved during the lifetime of the sensors, which is, I think I did the mistake here. I think so. No, there's no mistake. So, oh yeah, it's $5,628.35 during the lifetime. And let's now calculate the overall cost of this system. So the motion detection sensor cost. So in order to calculate it, I have first to sum the number of lighting quantity needed. So first I have to sum these numbers. And then I'm going to multiply them by 0.8, which is the price per unit. So as you can see, it's a very effective solution. So when I sum all these numbers, which is represents the overall quantity of lighting source I have, and I multiply them by $0.8 per 1 unit. So I get here the total amount of money needed. Then I can say simply that overall saving in dollar is simply the subtraction of these two numbers. Again, you can see here that it shows, I'm sorry, yeah, it shows a very positive number. There is a huge gap between what you are going to save and what you are going to pay for this system, and that means that typically it's very makes sense to go with this solution and to go with the energy saving process here related to the system. So this is simply how we can manage the energy auditing system. So by the end of this stage, my dear students, we have concluded that action number one, we don't need to make any replacement in the system because our running sources are more effective in terms of cost and power with respect to the proposed alternatives here. And our second choice or our second action is it is worthwhile to implement our motion detection sensors because simply the motion detection sensors will benefit the system with this amount of money with respect to the money I'm going to pay for this sensors across the board. So this is simply how we can conclude. Of course, we are doing a lot of assumptions here. We dilute the effect of inflation because simply the duration here is very limited. We are considering a lifetime of half a year for the solar for the lighting source and only 5 years for the sensors, which is not a big deal when you are going to consider dollar with about inflation rate of about 2.7%, as we are going to consider this in the PV sizing. So we can dilute the effect of the inflation rate. Of course, you can make it more accurate in your calculation and calculate the inflation rate, but as you can see, the gap is very big, so this will not affect your decision. Another point related also to that we ignore the electricity consumption of the sensors, and this is again a very basic and very makes sense assumption because simply sensors are alike current loads with a very low current consumption, usually in milliampere range. We are considering 100 to 200 milliampere range. So usually we can easily ignore the impact of their power consumption with respect to the system. So this is again a valid assumption, but of course you can make it in a more accurate manner, and you can calculate the typical power consumption of the load of the sensors, and you can add it to the system so that this is an added load. So instead of just making this 35% reduction, it will be also with an addition of the load power. So this is or the sensor power. This is typically concludes energy auditing with 3 stages, A, B, and C. And now in the next video, we are going to go to the PV sizing process. Thank you very much, and see you later on in a new part.